Today's lesson is on science, and I'm going to talk about reflection, refraction, and the difference between the two. And I'm also going to talk about lens and visible spectrum. So let's get started. Today I took a picture of our textbook. I'm going to read it through with you, and I'm going to highlight some key points. And the copies of our textbook is also available on our class website. So if you want to have a copy for yourself, feel free to find it on our class website. So first one, reflection. You have probably played with a mirror. So when you think about reflection, the first word, I don't know, for me, the first word that comes up to me is mirror. So I'm going to just highlight because that's really a good reminder for us to remember what reflection is. So you have probably played with a mirror and a light before. A mirror can bounce light in a new direction. It reflects light. Reflection is the bouncing of light off an object. So that's the definition for reflection. Most objects reflect some colors of light. When light shines on an object, the object absorbs or soaks in some of the colors. But the object also reflects some of the colors in the light. So observing meaning taking in. You see the colors of light that are reflected. The reflected colors give the object the color that you see. For example, a red hat absorbs all colors except red. The color red reflects back to your eyes, and that is what you see. Same for the green hats. Green hat reflects the color green, but it observes the other colors of light. So here are the examples of a red hat and a green hat. So what the textbook is saying is that when the light strikes the head, all other colors are getting observed except for the red color. That's why it's bouncing off, and that's what you see through your eyes. Then what about the white hat? Usually, an object does not reflect only one single color of light, but several colors. Your eyes and brain combine these reflected colors. The great variety of colors that you see is the result of these combinations. Some objects reflect all the colors of light. When this happens, you see white. So white is when the objects reflect all colors of light. Other objects absorb all the colors of light. When this happens, no colors are reflected and you see black. So black means no colors are reflected because everything got wet. Observed. So let's look at the picture. So do you see the rays, the two rays? That means a light is striking the hat and reflecting all the colors. That's why you see white. On the other hand, when we look at the black hat, we only see one ray, the light that's striking the black hat. However, there is no bouncing off beam, which means there is no color reflection. And if that's the case, you only see the color black. Then let's talk about refraction. Refraction is one way for light to change direction. Another way is for it to bend. The bending of light as it passes from one substance to another is called refraction. I know right now it's you might find it hard, but I'm going to explain it later. So let's just read along together. Light moves very fast. I talked about this, how fast the light is, but it does not always travel at the same speed. It travels at different speed in different substances. This is something that you need to remember because we all know that how fast the light is. However, they travel in a different speed depends on the location. So let's look. When light travels from one substance to another, it refracts or bends. The light changes its speed and direction. Perhaps you have seen a spoon that looked bent when standing in a glass of water. Light that reflects from the top of the spoon moves only through air, but light that reflects from the bottom of the spoon also moves through water. Air and water are different substances. Light does not travel at the same speed in each of them. When light passes between the water and the air, it is refracted. I'm going to highlight this too. This causes the spoon to look like it is bent. So let's look at the picture here. The item inside the beaker is not a spoon, it's actually a ruler. So what the textbook is saying is this. When the light is traveling in the air, we see this angle. However, because light is traveling in a different speed, when it's striking water, we see a little bit of bending. So even though this is a straight ruler, because the substances are different, we see different angle for the ruler. So that's what I mean by refraction. So it's changing the angle. That's refraction. And why? Why do we have refraction? It's because light is traveling at different speeds in different substances. Okay? Then let's go to lens. Ooh, magnifying glass. If you reach into a fish tank and try to pick up something in the water, you can see the effects of refraction. You may reach in one place to grab the object, but discover the object is not actually located there. The light reflecting off the object refracts as it moves from the water to the air. To your eyes, the object appears to be in a different place from where it really is. To help them see things better, people have made many tools that use refraction. Some of these tools use a lens. A lens is a transparent material used to reflect light. So, here's another word that we've been learning. Transparent. So lens is a clear material, clear glass used to refract light. When you use a magnifying glass to look at things, you are using a lens. The lens bends light to make an object appear larger than it actually is. Microscopes, telescopes also use lenses. So those are the two examples. Microscope lenses magnifying things that are too small to be seen without help. A telescope magnifies things that are very far away. So the difference between microscope and telescope is this. Microscope, okay, here is a picture of microscope. Microscope is used to see something that's very, very small. So magnifying glasses is also one example. So for example, let's say we're looking at a tiny coin and we want to look it closer. Then we use the microscope to see it bigger. What about telescope? Telescope is used to see things that are very, very, very far away, like moon. So those are the examples that we use to see things more clearly, and the principle behind it is the refraction. So it's not always the water that's refracting an item. It's also the microscope and lenses. And there are the examples. There are the two examples. And let's look at the last page. Colors of light. You may think of light as being white, but light is actually made up of many colors. All the colors that make up light are called a visible spectrum. I'm going to highlight this. One way to see the colors of the visible spectrum is to look at a rainbow. After the flood, God promised He would never again cover the whole earth with water. God chose the rainbow to be a beautiful reminder of this promise. The colors of the rainbow are always in the same order: red, orange, yellow, green, blue, indigo, and violet. A way to remember these colors and their order is to think of the name Rho-G-Viv. Each letter of this name stands for a color of the visible spectrum. So, as I highlighted here, visible spectrum is a combination of all the colors. So let's look at the rainbow. So rainbow is one example of visible spectra. So just showing all different kinds of colors and the options for the colors, that's what visible spectrum is. So that's it for my slide, and I'm going to talk about the homework that I have assigned. So there are some examples of reflection and refraction, and I want you to identify which pictures belong to reflection and which pictures belong to refraction. So here is a picture of a mirror, and I see a beautiful mountain, and I see a lens. I think this is a lens, and I see a beam of light and straw in a cup, and here is a visible spectrum, I believe, and here is another bouncing off of rays. So here's my hint. When you look at the picture and when it's bouncing off at the same angle, then it's reflection because there's no change in the angle. However, when there is a change in the angle like this, that means it's reflecting the light, refracting. So those are the two identifiers. So please think about the difference between reflection and refraction. And I want you to complete this column with the pictures below. So that's it for my lesson today. If you have any questions, feel free to email me or chat me. And I've been seeing a lot of homework turning in through Google Classroom. I truly appreciate it. And if you need more time to upload your homework, please let me know. I can give you extension. And I really hope you stay safe and well. I will see you soon. Bye bye.